Okay, so now we're going to do some problems related to our special right triangles. So to recap, we have our two special right triangles. Our 45, 45, 90 triangle has this sort of relationship. The two legs, if we call those A, our hypotenuse is A root 2. Our 30, 60, 90 has the relationship if we call the short side A, the hypotenuse is 2A, and the long side is going to be A root 3. Okay, so if we use that to do a few examples, here we go. So here's my first example. It's a 45, 45, 90 triangle, and I have one of my legs. Well, I know that if I have one of my legs, and I can set this up, I'm going to set it up for this one, even though it might not feel like I need it. Normally in our triangle, the side opposite the 45-degree angles are going to be A, and the side opposite the 90-degree angle is A root 2. So this is a lot like what we did for those of you that have been in class, what we did in class, and for those of you that were not in class, you might remember this as that little table off to the side. Okay, so I'm going to enter in what I have. What I have is a side opposite 45-degree angle equaling 8. So now if A equals 8, well, the other A must also equal 8. And then this side is going to be a side length root 2. So it's going to be A root 2. So doing this isn't really sufficient. You want to, whenever you're doing these problems, you want to find the missing sides. And so I would write that in. So 8 root 2, and then 8 as my other side. Okay, now let's do this one. Now, I'm well aware that the scale looks really weird. Go with it. Go by the labels, not what it looks like. Okay, so if this is also 45, then what I'm going to do is I'm going to draw my table 45, 45, 90, A root 2. And what I have is I have the side opposite my 90 is 15 root 2. So some of us might notice that A must be 15, and those people would be right. Now, if you didn't notice that, you can always think of this as an equal sign. And so A root 2 equals 15 root 2. To get A by itself, we divide both sides by root 2, and we'd get 15. Okay, so if you ever look at it and you're like, geez, I don't know, you can always take whatever's above, whatever's below, and set them equal to each other. Okay, so now my job is to label the sides. Okay, here's our next one. So now, if I look at these, so this one looks a little different. This one is giving me a leg as 7 root 2. That's weird. So we might think, oh, this is labeled wrong. It's not. It's just a different looking side, and that's fine. So I'm going to write my table, thinking about my special right triangle. The side opposites my 45 are A, and the hypotenuse is A root 2. And I know that a side opposite a 45-degree angle is 7 root 2. So what that gives me is that A is equal to 7 root 2. That's really the big question you're trying to find for yourself is, what is A? So that means this other side must be 7 root 2. And then, okay, this one's different. So I'm going to kind of do a bit of a thought bubble here. Well, my hypotenuse is A root 2, and A is 7 root 2. It doesn't mean the root 2 goes away. It means we have to multiply it, okay? So 7 times no other coefficient is 7, and root 2 times root 2. Well, don't forget, that's the same as root 4. And we know root 4 is equal to 2. 7 times 2 is equal to 14. Okay, so that means my hypotenuse is 14. That's a different kind of problem. That's looking a little different, okay? A little harder. Here's another one that's going to be a little harder, okay? So for this one, okay, well, we're given the side across from the 90. And that side is equal, normally a root 2, a and a. And we're given that that side is 22. And so remember with the one directly above this, with the 15 root 2, well, if we don't know something, we set it equal to it. And so I can create an equation here. A root 2 is the same as 22. So I'm going to divide both sides by root 2 because I want to know what a is. If I know a, I know everything. And those cancel, but I want to get rid of this root 2. So I'm going to multiply both the top and the bottom by root 2. And I get 22 root 2 over root 2 times root 2 is root 4. And that's the same as saying 2. Now this can simplify, right? My root 2 can't simplify, but 22 divided by 2 is equal to 11. Okay, so that means A is 11 root 2. So that means that this is 11 root 2, and this is 11 root 2. And there's a whole bunch of different patterns people notice. Like they notice that when you have a whole number here, this is that whole number divided by 2 root 2. There's all sorts of little patterns, and that's completely fine. Yes, those are true patterns. They work every time. You just might not be able to follow using patterns all the time. My brain doesn't really work that way. Okay, so now let's go ahead and try another type. So now let's go ahead and look at our 30, 60, 90. So if we look at this, if I label, well, for whatever reason, guys, my brain thinks about a triangle set up a different way. So if you're like me, you can rearrange any of these triangles to look like the triangles we've been looking at, but you don't have to, okay? So if you want to redraw this one to be in the same orientation as what we've been doing, that's fine. So this is the orientation we've been doing. Okay, but it's up to you. So then I'm going to write my table. The side opposite the 30 degrees is A. The side opposite the 60 degrees is A root 3. And the side opposite the 90 is 2A. Now let's see what we have. We're given the side opposite my 30 degree as 8. Remember, if you have A, you have everything. Okay, so we've got A. We've got everything. The side opposite the 60 degrees is A root 3, so it's 8 root 3. And the side opposite the 90 degrees is just double A. And so if I label my sides, side opposite the 60 is 8 root 3, and the side opposite the 90 is 16. Done. Not to scale, not even a little. Oh, well. Let's go ahead and try the next one. So this is 30. I'm going to set it up the same. I like this one. 30, 60, 90. Sometimes people ask me, do I have to write this down? No. The whole point of these special right triangles is that you get so good at them that all you write down is the sides. Okay? But until you get there, writing this down is one strategy. So this is normally A root 3, 2A. The side opposite my 90 is 14. Okay, well, that's not too bad. If I have A, I have everything. Well, if 2A equals 14, then A is 7. And if A is 7, then A root 3 is 7 root 3. So the side opposite 60 is 7 root 3, and the side opposite 30 is 7. Cool. So those are ones where you easily, as you get good at these, you might not have to write all that down. Now, this one might be a little bit more something you need to write down. So now if I do this one, what I end up getting is I have 60 here, and what I notice is 30, 60, 90. Notice I'm starting them off the same way. Opposite the 30s, A, opposite the 90s, 2A, and opposite the 60 is A root 3. So, and what I have is the side opposite the 90, and that's 4 root 3. Now, this one might be a little weird for you. You might know right off the bat what it is, but you might not. So if you don't, we can set up an equation. That's the whole point. 2A equals 4 root 3. If I divide both sides by 2, I get A equals 4 divided by 2 is 2 root 3. Cool. If you have A, you have everything. 2 root 3. And then, this one might be another weird one. Well, what I have is A root 3, 2 root 3 times root 3. Well, 2 times 1 is 2. Root 3 times root 3, well, that's root 9, which is 3. And 2 times 3 is 6. I went through that really fast. If you want to rewind and watch that part again, feel free. That gives me 6. And all these answers look very strange, right? But they all come from the fact that these are all similar triangles and we have common relationships here. So the side opposite the 30 is 2 root 3, 4 root 3, and 6. Okay.